Dear friends, welcome to Infos. Welcome to Oil and Gas training series. Welcome to Heat Exchanger. So, this is Heat Exchanger part 4. In this video, we are discussing about process control of heat exchanger. What are the different type of control system which is using to control the efficiency or control the temperature inside the heat exchanger, or the best operating parameter maintaining, or normal operating values, or alarm conditions. What are the alarms or abnormal values deviating from the set point, or what are the safeguarding condition for heat exchanger. So, control system means I have already prepared and posted around 10 numbers of videos on process control. I kindly request you to watch that one. I will add that all link of a playlist inside the description box, so you can find out that one easily. What are the basic instrumentation like sensors, transmitters, controllers, and final control element, the basic control loop and the basic elements in a control system. So before going to understand this one, going to the inside of this process control of heat exchanger or any equipment operation, control system is very important as a part of process operation. So welcome to this video. So the main purpose of heat exchanger is to maintain specific temperature conditions, which is achieved by controlling the exit or inlet temperature of the process fluid in response of variation of operating conditions. So the main purpose of heat exchanger is to maintain specific temperature conditions, the best efficient heat transfer at operating at safely and efficiently. That is our main purpose. So process variable in related to heat exchanger, not only heat exchanger, in any other process operation equipment is pressure, temperature, flow and level, at least 4 important process variable. So in heat exchanger, always temperature is maintaining with shell side and tube side, or hot fluid and between hot fluid and cold fluid, any of this one. Temperature is the ultimate aim to improve better heat exchanger, better heat transfer between two fluid. That is our ultimate aim in heat exchanger. Temperature, pressure, flow and level. By maintaining temperature itself we can do this one, or pressure we will adjust, flow we will adjust, or level we will adjust. By different way we are doing that one. So control objective: to develop a comprehensive control strategy for any control loop, it is important to identify the process variable of interest called control variable. It is manipulator and the manipulator variable and the different disturbance variable that directly affect the control variable. I already discussed in instrumentation what is control variable, what is the process variable, what is manipulator variable, and different disturbances or error, etc. Already discussed that one. So that's why I'm not going to be in detail of that one. So these the parameters specifically know that one, then only we can do the efficient design the efficient control loop. So importance of process variable control in heat exchanger is better heat transfer, efficiency in operation, proper control in operation. So heat exchanger is a critical equipment. A temperature increasing or decreasing is a difficult process to control. If temperature is going to out of control, it's a difficult or a hazardous situation can arise. So controlling is very important in heat exchanger. How to achieve it? Design a suitable control loop to get a better heat transfer without upset the process using temperature, pressure, level or flow, the process variable. So any of these 4 process variable control in a such a way that one to maintain better heat transfer, efficiency in operation, proper control in operation. So process in heat exchanger: Heat is transferred from the tube fluid to shell fluid to remove heat from from the shell fluid to tube fluid, heat the material inside. Fluids can be liquid or gases on either the shell side or tube side. To transfer heat efficiently using a control logic or control loop, design a control loop to efficient heat transfer between fluids and steady stable operation with the minimum process upset. So this is the simple control loop. This is a simple control loop. In that one we studied already, we have discussed in process control the elements in a control loop. The number one is a sensors is there. See, the sensor is here in this process line, either in a cold fluid or hot fluid we can put the sensor. Then we will put a transmitter. The sensor is giving the temperature signal to transmitter. Transmitter will convert the receive and convert the signal to a standard form, either electric or a pneumatic signal. Then it is going to a controller. It is a controller. Controller has a inbuilt or previously pre-designed set point will be there, plus the process variable PV value is coming from the field. So set point, the controller is comparing with the set point with the PV. So and the deviation is there, error is there, means the output will produce, that is the manipulator variable, to the final control element, which is the valve. And before going that one, if it is the controller is a electric controller, then the output will be in the electric 4 to 20 milliamps. And most of the cases final controller control valve is final control element, control valve is a pneumatic controller. So we use a I2P converter or transducer in the outside, in the near the field, to convert electric signal to pneumatic signal, electronic signal to pneumatic signal. That is why this is a dot line, and this is a single line with a cross. So it is a pneumatic line representing in P and ID. So that is there. And the deviation signal, the error signal going to the final control element, which is a TCV here. So it will adjust, controller will give command to the TCV to adjust to open or more to maintain the temperature at set point. So this is a simple control loop. You can imagine that one: sensor, transmitter, controller, converter, and control valve. This much of simple device is there in a simple control loop. So this is most of the cases heat exchanger is using in simple control loop, plus some of the heat exchangers are using nowadays little more advanced type heat exchange control loop, advanced type control loop in heat exchanger, controlling for I told you, better stable, efficient, safe operation. So different type of control system. This one is a simple control loop, you can say. So this is also a simple control loop, you can say. It's called a feedback control. See, sensor is here and transmitter is there, controller is there, I2P is there, and control valve is the simple one. And cold fluid is entering from here, and cold fluid is better heating and going out, and hot oil is coming from the top side here I mean through the valve, and hot oil is going here. So our aim is to think about the control logic here. Our aim is to product out to temperature maintaining using the hot oil in and out. So the hot oil flow is we are maintaining, and we are controlling the temperature in the product line. So look at that one, valve is in the hot oil side, and the temperature sensor and transmitter is in the cold fluid side, heating side of the product side. So in the feedback control system is a simple control loop. The feedback control system, the outcome of the controller action is feedback to the controller for corrective action. Always output for the controller. So controller action, it will always going to feedback to the controller again, controller action. Feedback controllers can only react to correct a load upset after an error is detected between the process variable and set point. So always it is the process variable coming from here, and it is producing an error or output, then it is reacting. So it is that is the how the feedback control is working. Feedback controllers can only react to correct. See, reacting when the process variable is coming here. If the process variable is equal to set point, there is no change. But if the process variable is above or below the set point, the corrective action or error is producing, and control valve will open or close slightly, will regulate, adjust the flow to get the temperature again at set point. So feedback controller is recovery slow for major upset. That is the only limitation for feedback controller. To improve a control system with a minimum fluctuation and stability, more stability, the instrumentation improvement, instrumentation engineering improvement is there. Another one is a feed forward controller. See, feed forward controller, you can see that one earlier only temperature transmitter and temperature controller, then temperature control valve. Look at here. Here it is two controller is there. See, temperature controller is there. Another controller is there. It is called flow controller. FT is there. It is name is not written there. FC. So and it is taking the reading from the hot oil flow also taking. See, before going to control valve, it is taking hot oil flow. Flow transmitter is there and flow controller is there. And in between, see the product in, they are taking the temperature in and flow in. So see how many parameter they are taking. Product outlet temperature, product inlet temperature and flow, then the hot oil flow. So 4 parameter coming to, and 2 parameter coming to a, it is a mathematical calculator is there to all this 4 parameter calculating according to in such a way that you want to maintaining a smooth temperature, stable temperature control in the product line and stable flow in the hot line. So this way they are maintaining that one. So feed forward controller work together with a feedback controller. So it is designed or developed from the feedback controller itself. Feed forward controller adjusts the output of the feedback controller by monitoring process changes in advance. So they will always process changes in advance. See the flow here and flow here also, it is taking in advance, then calculating, making a smooth decision to maintaining a minimum fluctuation or more stability in the process. This action reduces the fluctuation. So this is another control system. Most of the cases our control systems are, modern control systems are feed forward. And in heat exchanger we are using another controller. This is a simple control loop and we are using cascade control system. See what is the difference in cascade control system? For understanding cascade control system, you should go to understand simple control loop. See, sensor is here and you have transmitter is here, controller is there and control valve is there. This is a simple control loop, this one, and how the changes is there in cascade it is coming. How the cascade is coming. Earlier temperature sensor here, transmitter here, temperature controller, up to this the same control system, a simple loop, but after that one the controller output, temperature controller output is not going to control valve here, it is going to another controller. It is a flow controller, it is a cascade with the temperature controller. So set point is also here, here also one set point is there. So this output deviation error going to set point of this flow controller. So that is cascaded. So and that's cascaded controller receiving a flow from the steam lane, the hot fluid lane. So it is comparing with that one. So two controller is using in cascade and simple control group it is using only one controller. In a simple way to understand this is you can remember in your mind. And in simple control loop only one controller. In cascade control loop it is two controller we are using that one. So one is master, the temperature controller here in the example is a master controller, and this cascader controller we called slave controller, like that one. It is a instrumentation name it is using that one. So it is a cascade. So it is another variable it is taken, and this control valve name will change based on the cascading logic. Earlier in the simple control of this control valve will be TCV, temperature control valve, but here in the cascade control loop this control valve will be FCV, flow control valve. So this is a, by cascading control system we can maintaining a less fluctuation, better efficiency and stable operation without much affecting the process upsetting in the heat exchanger. This is not only using in heat exchanger, many other places are using. So one example I have taken from heat exchanger. So different type of cascading also available. So earlier I told you that one in temperature flow cascading is there. So like that one, pressure temperature cascade is there. In the heat exchanger, same is there. Feed is coming, product is going, steam is coming, and condensate is going. It's a condenser. So in that one, pressure temperature cascading. See that one? Pressure temperature is taking from the product. That is ultimate. Our aim is to temperature controlling. This is our required temperature to maintain. So this is the normal operating value. So this is temperature transmitter is there, sensor is there, transmitter is there, and controller is there, temperature controller. And temperature controller output, in this case the deviation and output is going to pressure controller. Here is a temperature pressure cascade. So the second controller is a slave controller, is a pressure controller. Then the pressure controller is taking the pressure from the steam line, pressure transmitter is there. So then that will go to the pressure controlled valve. See, look at that one, a pressure controlled valve is there. So temperature pressure cascade is also using in heat exchanger, plus temperature flow cascade also using. In the earlier example I saw that one, temperature show that one, temperature flow cascade also. See, it is temperature transmitter and controller is a primary controller, then is a flow indicator controller or flow controller. It is taking flow transmitter reading as well. It is a secondary controller, steam valve. So pressure temperature cascading systems are using in heat exchanger widely, plus temperature flow cascade, that is the most widely using, temperature flow cascading in heat exchanger for better and efficient heat transfer and heat transfer control system. So look at to a P&ID, simple P&ID. I kindly request you to take a P&ID from your field or from your area of operation and read it in such a way you understand that on heat exchanger. Not only for heat exchanger, all equipment, understand each and every parameters in here in heat exchanger or symbolic representation of each instrumentation representation. So you will be very good in heat reading of P&ID and understanding the process. Look at that one, the process equipment is there, E101, that is a heat exchanger, and steam is coming. See, the steam is coming to go condensate, and the feed is feed is entering through the pump and going to a hot fluid is here. Here there is a control system is there, forget about that one, that is a flow controller after pump outlet to maintaining a constant flow to the heat exchanger. Forget about, our aim is to this product, this is the product hot feed, this is the product temperature we are controlling here. See the temperature here, temperature transmitter is there, and there is a controller which is it's a old type controller, temperature indicator recorder control, TIRC, little bit old P&ID. So nowadays it is in the new PLC system it will write TIC, temperature indicator controller. So in that one, in that controller, see another information available. See, temperature alarm low, TAL, plus temperature alarm high, that I am coming to our my next slide. So this two information also it's connected to this P&ID. Then the output is going to TV, then this is a TCV, a pneumatic signal. And here main things are there in the steam line, pressure transmitter is there, pressure indicator is there, pressure alarm low is there, and steam temperature is taking and temperature indicator, and steam flow also taking and steam flow recorder is there. And in the heat exchanger itself, in the shell side, there is a pressure transmitter is there and the pressure indicator is there. This is why in the shell side I will discuss in my coming slide. So this is one of the P&ID, but in that one there is no much control is not available here, but one important control process variable I can say that in this process variable, this is a kettle type here reboiler. So this is a heating coil is there on the tube side, this is the heating coil is there, but here we are maintaining a level. The hot fluid level we are maintaining, and the cold fluid cold fluid level we are maintaining, and hot fluid is passing through the tube side, and the tube is immersed in the cold fluid level. So that's why see the level indicator is there, and level shutdown logic is there, level indicator transmitter is there, level glass is there, level transmitter, indicator transmitter is there, and level indicator controller is there. So level indicator controller signal going to somewhere here. So it is maybe in this one, it is allowing to fluid out, hot fluid or cold fluid in or out, to maintaining the level. That's why the heat is maintaining here. Temperature is maintaining by maintaining the level here. See that one. And plus, this also important, in the tube side, see the differential pressure also it is taking care. In any case, not in the tube side, in the shell side. Shell side differential pressure also taking care. I will show you that why it is a differential pressure is taking in the shell side. So that is also there, and temperature indicators are there. Control valve is not showing here, and level sensor and transmitter and controller is there. It is going to somewhere, and one of the hot fluid or cold fluid line. Okay, this is one simple P&ID. And another P&ID is shell and tube heat exchanger, but there is no control system is there, and temperature sensing element and transmitter is there, plus a PDI is there, differential pressure indicator is there. Only that much information is there. And safeguarding system that I already show in the P&ID, 1 or 2 safeguarding. So two type of safeguarding system is there, not only two type, many types are there. But in heat exchanger we are using some alarms, we are using, that is the alarms which I show that in the P&ID: temperature alarm low, temperature alarm low, and temperature alarm high, level alarm low, and pressure alarm low. So various alarm showing to low value or high value. Actually this alarms value is a deviation from the set point or normal operating point. From normal operating point, the process variable is deviating from either side. We will fix it as a alarm to giving the sufficient protection to the heat exchanger. So alarm will not take any action, alarm will annunciate, and alarm will intimate the process operator, control room operator, and field operator, or control room operator, and communicate, or control room operator has to take a proper decision to rectify the alarm condition and maintain the operation of heat exchanger safely and efficiently. So another is a trip condition is just to another or normal operating value or set point is deviating highly from alarm set point range. It is going to either side. You can say that on temperature high, temperature low, or temperature switch high in the field, or switch low, or pressure switch low, or level switch low, like that one. You can see that one in this drawing. You can see that one here. See, it is in the control room. In the controller it is there, in the LIC it is there, level switch low is there, level alarm low is there, and high is there. See, in the PLC controller right side it is written low and high. So PLC controller is programmed itself showing to an alarm on high liquid inside and or low liquid inside to protection of tubes against thermal damage. And here also the PDT, you look at the PDT, is there any differential pressure is increasing that one. In the shell side it is in the control room it is showing a differential pressure alarm high. So it is confirming that one, the shell side tube side is leaking, and shell side fluid is both fluid is mixing together, and shell side pressure is increasing. So that's why tube side tube is maybe leaking problem or some other problem is there. So we have to cross check and inspect, further inspection to do. So here also in this one also PDI is there. So always in the shell side they will do that differential pressure indication, or pressure itself showing that indication for confirming that one fluids, both fluids are not mixing and the tubes are not leaking. So trips and alarms are safeguarding heat exchanger. Not only heat exchanger, many other all process equipment. And trip condition will activate not only alarm, it will activate a trip. It will close some of the valves, or it will open some of the valve, or it will trip some pump or motor, etc. like then the trip condition will take action in a trip logic, and differential pressure high also will give a process safeguard in the heat exchanger shell side, tube side leaking to identify that one. And pressure high also, they are using sometime pressure high in the low pressure fluid side for a safeguarding operation. So thanks for watching this video. I hope you understand heat exchanger control system watching this video. So if I kindly request again to just to review my process control videos for better understanding basic control system and how it is using an advanced control system as well, like many other positioner and solenoid valve, different type of control element, controllers, transmitters, etc. So that will give a good idea on process control. So thanks for watching this video. Have a good day.